Let's solve the following differential equation. So here, if we consider the right hand side of this differential equation and denoted by the function f of x comma y, we'll see that if we make the substitution x with lambda x and y with lambda y, then we will get back our original function f. And whenever this criterion is met, we say that our function f is a homogeneous function. And since our function is homogeneous, our differential equation is going to be a homogeneous differential equation. The next step would be to solve this differential equation. Now, the only issue is that we cannot apply the method of variable separation to solve this differential equation. That's because our function f, this cannot be expressed as the product of two functions, g and h, where g is a function of x only and h is a function of y only. But there's a trick to that. If we make the substitution y over x equals to v, that means y equals to vx, our differential equation reduces to a variable separable form. So let's do that. So we will differentiate y equals to vx on both sides with respect to x. So we have dy over dx, that will be equals to v plus x times dv over dx. So let's use these two substitution and rewrite a differential equation. So we have 2 times v plus x times dv over dx equals to, we have y over x, so that will be replaced with v plus y over x whole squared, so that's v squared. So this means we have 2v plus 2x dv over dx, which is equals to v plus v squared, or 2x times dv over dx equals to v squared minus v. Now we can separate the differentials to get dv divided by, we have v times v minus 1 to dv, and this is equals to dx over x. So this is now in the separable form. So let's integrate both sides. Now to integrate the integral on the left hand side, we'll have to use the method of partial fractions. So that means we'll have to rewrite our function 2 divided by v minus 1 as the sum of two fractions, partial fractions, a over v minus 1 plus b over v. Now, we'll multiply throughout with the denominator v times b minus 1. So this will be 2 times v times a plus v minus 1 into b. So let v be equals to 1. When v is equals to 1, then a will be equals to 2. And when v is equals to 0, b will be equals to negative 2. So that means our integral now reduces to, we have a over v minus 1. So a is 2. That will be 2 divided by v minus 1 dv minus 2 over v dv equals to integration dx over x. Now each integrals are fairly easy to compute. So integration of 2 over v minus 1, that will be 2 times natural log of v minus 1 minus 2 times natural log of v equals to integration of dx over x, so that's natural log of x plus the constant of integration, but we'll take log of c. The reason being every term is in terms of log. So log of c is the constant of integration. Now we can use the property of logarithm to raise 2 as the power of v minus 1. That means we have log of v minus 1 squared minus log of v squared. And this will be equals to log of x times c. All we are doing is we are combining the two logarithm on the right hand side. We can again combine the logarithm on the left hand side as log of v minus 1 divided by v whole squared equals to natural log of x times c. Now we can do is get rid of the logarithm from both sides to get v minus 1 divided by v whole squared equals to x times c. Now v is y over x, so we will replace v with y over x to get y minus x divided by y whole squared equals to x times c, or simply put, we have y minus x whole squared equals to xy squared times c, and this is the required solution to a given differential equation.